All right, so let's take a look at this homework, creating geometric recursive equations, okay? So, again, remember with the geometric, it's all about the multiplication and division, okay? Arithmetic is the addition and subtraction. But when we do recursive equations, we always start with a sub n equals a sub n minus 1 and a sub 0 equals, okay? In the case of arithmetic, we add or subtract right there. So in geometric, we're going to multiply. Actually, we don't write the multiply, huh? We do the dot, multiply or divide. Yet, even the divide we don't really want to do. We want to change it into multiplication. Okay, so on this first one, I know I've got a sub n equals a sub n minus 1. And then I'm going to have a sub 0 equals. So for the a sub 0, we want to know where we start. So this is actually not the start. That's our first term, okay? And there's two smiley faces. Then we go to 6, then to 18, and then to 54. So hopefully we notice we're times them by 3. That's our constant ratio, right? So we would just put times by 3 right there. And then for our start, we go backwards. So what times 3 would equal 2? Or just go 2 divided by 3 and we'd get 2/3. So you'd have 2/3 of a smiley face for our starting number. Okay? And that's really all there is to it. So, alright, let's take a look at the next one. Okay, so I know it's going to be a sub n equals a sub n minus 1. And then a sub 0 equals. So I go from, looks like I have 9 here, right? 2, 18, 2, 27. So it looks like I'm, oh wait, not 27, what am I thinking? No, I was right, wasn't I? Yeah, 27. Okay. However, that's not going to work, is it? Because that's not geometric. So that's kind of a crappy deal. So let's think of it this way. If we thought of it in rows, would that work? There's 3 rows, 6 rows, and 9 rows. Yeah, that's not going to help us. Alrighty then. So this one, we're just going to pretend like over here, there's a few more of these. We're going to go like that. Then we get here. Now it's going to work. So triangle-wise, we start with 9. Then we have 18. Then 36. So now we can see that we are actually timesing by 2. So timesing by 2 here. So going backwards, if we cut it in half, that would be 9 halves, which is also 4.5. Okay. Well, sorry about that. There wasn't enough there. Okay, now number 3, we're not counting boxes here. We're counting how many sides. So we've got 4 sides in our first term. 12 sides here. And 36 here. So 4 to 12 to 36, we are times them by 3. So I know to get the next term, I take the previous term and I times by constant ratio of 3. Working backwards, I divide by 3, and my starting number would be 4/3. Okay, so there we are with the picture patterns. Now let's take a look at the story problem. So again, though, on all of these, a sub n equals a sub n minus 1, and a sub 0 equals. Okay, I'm going to always use that, whether it's arithmetic or geometric. I know I'm always using those, and then just depending on what the pattern is, that determines if it's arithmetic or geometric, so whether I multiply or add or subtract. So, the number of dandelions growing on your lawn triples every 3 days. If your lawn started out with 15 dandelions, okay, there's my start number, 15. How many dandelions would you have after 3 weeks? Okay. Again, we're more worried about the equation than actually answering. Okay. So it triples meaning times by 3, so we times by 3 there. Okay. Apparently forgot a T there. So number 5, the population of a town is increasing by 2% each year. The current population is 12,000. How many people will there be in 4 years? So 12,000, okay, is our current population. That's our start number. Okay, then we're growing by 2% each year. But don't just go times 0.02 for 2%. Because actually, this amount of people is going to stay the same. That's 100% of the people. So 100% plus 2% is 102. So I'm timesing by 1.02. Okay. Number 6, a population of insects doubles every month. If there are 100 insects to start with, how many will there be after 7 months? Okay. So, if we look at number 6, doubling means times by 2. There's our constant ratio. And we start with 100. Okay, they double every month. And there's our formula. If we really wanted to, we could go 100, double it. So, in month 1, there's 200, month 2, 400, month 3, 800, month 4, 1600, month 5, 3200, month 6, 64, and month 7, there'd be 12,800, if you wanted to know. Okay, for your population, if you really wanted to know, the first month of growth would be 12,240. Second month, 12,484.8. Third month, 12,734.5, so you have a half person. And then the fourth month, 12,989. And a decimal, but we don't count that. If you wanted to know dandelions, well, every 3 days, in 3 weeks, that's 21 days, so basically 7 periods. So if I go 15 and times it by 3, my first 3-day set would be 45. Then my second 135. Third, 405. Fourth would be 1,215. Then fifth, 3,645. The sixth would be 10,935. And finally, that seventh set of 3 days, so the 3 weeks, 32,805. That's a lot of dandelions. Okay? All right, now if we take a look at these ones, we're just using the patterns, and we're going to figure those ones out as well. So again, on all of these, I know that this is how we set it up. Okay, so I can write these in to start off. So we just figure out the growth first, right? That constant ratio, 3 to 15 to 75 to 375, times them by a positive 5, not negative 5. It's only negative when they swap. Okay, so times by 5 here. Then going backwards, negative 3 divided by 5, negative 3/5. Okay, number 8, 4 to 12 to 36 to 108, times them by 3 each time here. So times by 3. Going backwards, negative 4 divided by 3, give us negative 4/3. Okay, then number 9, 4 to 16 to 64, we are times them by 4 each time. So, and it's negative to positive, so it's actually a negative 4. So times by negative 4, going backwards, negative 4 divided by negative 4 is going to have us start at 1. Okay, number 10, Again, negative to positive, so I know that it's going to be a negative 4 that we're timesing by. Again, Okay, then going backwards, negative 2 divided by negative 4 becomes a positive 1/2. Okay, 11, 2 to 8 to 32 to 128. That's like number 10. The only difference is it's going to be a positive 4 we're multiplying by. So going backwards, negative 2 divided by positive 4 gives us a negative 1/2. Okay, 12, 2 to 12 to 72, times them by a 6, positive to negative, means it's going to be a negative. Going backwards, 2 divided by negative 6 reduces to negative 1/3. You can use decimal equivalents if you want to for those starting numbers. Okay, 13, 2, 4, 8, 16, times them by 2. Going backwards, 2 divided by 2 would give us 1. 14, and I'm forgetting to do it in my certain colors, aren't I? I think I'm cool and do different colors and then I always forget. So 4 to negative 8 to positive 16, times them by a negative 2 there. So going backwards, 4 divided by negative 2 gives me a negative 2. Number 15, 1 to negative 6 to 36, times them by a negative 6. Going backwards would be negative 1/6 because I'm dividing by a negative 6. Okay, 16, 4 to 8 to 16, timesing by a negative 2 again. Oops. And then we would get, going backwards, negative 4 divided by negative 2 be a positive 2. Alright, now these last four, you're determining if the sequence is geometric. If it is, find the common ratio, the recursive formula, and the 3 terms in the sequence after the one given. Okay, so 4 to 16 would be times by 4. If I times by 4, do I get 64? That is true. So I know it's a sub n equals a sub n minus 1 times 4. So my common or constant ratio is 4, timesing by 4. Okay, so let's write that, circle it. Okay, then my starting number, a sub 0. If we go backwards, negative 4 divided by 4 would give us a negative 1. Now, if we wanted to keep going on this, right, we just go 256 times 4. That's 1024 times 4 is 4,096 times 4, 16,384. Okay, for 18, our common ratio would be 4 to 8 to 16, we're times them by 2. Okay, so that would be 64, 128, and then 256. So recursive formula, a sub n equals a sub n minus 1 times 2. Then we would start, we'd have to start with 2, right? Because 2 times 2 equals 4. Number 19, 2 to negative 12 to positive 72, times them by negative 6. So common ratio, negative 6 timesing. Okay, so a sub n equals a sub n minus 1 times a negative 6. Oh, by the way, those would have all been negative. I meant to say negatives. Okay, start number, 2 divided by negative 6 would reduce to negative 1/3. To keep it going, 432 times negative 6 would be a positive 2592. Times that by negative 6, negative 15,552. Times that by negative 6, and a positive 93,312. Then our last problem here, negative 1 to negative 6 to negative 36. We're again timesing by a 6. This time it's positive. So 216 times 6 would be 1296. Times that by 6, 7,776. Times that by 6, and we get 46,656. So common ratio, constant ratio, timesing by 6. And the formula a sub n equals a sub n minus 1 times 6. A sub 0 equals negative 1 divided by 6, or negative 1/6. Okay, and there you guys go.